In this video, I will talk about functions, a very powerful construct in almost every programming language. Python also supports functions. What a function is, let me describe the need of the function by a scenario. Let me give you a scenario. The scenario is, let's say you are writing a very lengthy program. The program requires to print particular messages whenever needed. For example, you need to print this particular message, the task was successful. Let's say you need to print this, and then you have to print moving to the next task, maybe to inform somebody, maybe to inform your client, and then you have to ask, okay, send me the next task because I'm done with the previous task. Let's say you want to print this, or maybe you want to print more or do some more stuff. And let's say you want to do this again and again whenever needed. Somewhere, whenever you complete a particular task or something, you want to print all these messages. And then somewhere else, whenever a particular event occurs, you need to print all these messages again. Now, one way to do that is to write just these print statements whenever needed in the program. One way is, if you want to perform a task and the task has a lot of coding, maybe very small amount of coding, or maybe a very large amount or magnitude of the coding. In this case, we have just 3 statements, but maybe we have a task that we want to perform again and again, and it is really a very lengthy task in terms of the coding. So one way to do that is to just write all the coding in coding somewhere and define a function. And that function means the function contains all the tasks that you need to perform. Whenever you need to perform that particular task, just in your coding, just call this one statement, and the whole task that is written under this, maintaining this as a heading, that will execute automatically. That task that is under this heading may be very lengthy, maybe short, maybe complicated, maybe simple one, or anything. But the need is, we want to perform this task whenever we need, and we do not try to code this again and again. We do not want to write the same lines of codes again and again and again and again in our program. Just write this particular lines of code once, define a function, just like a task. Whenever you need to perform that task, just call the heading or the name of the function, and the whole task under that function will execute. Functions in almost all programming languages, they do that. Even in mathematics, they do that. In Python, the syntax of defining function is, if you want to define a function, you have to first start with DEF, meaning definition or defining. Then you need to write the name of that function. The name of that function, name of function and name of variable has resemblance. the name of function should be descriptive. It should portray what the function actually is doing. So it is good to suggest the names of the functions that are very descriptive to make the code readable and manageable. So here I have written the function name as print success. You can write any name. Then you start parentheses, then you end parentheses, and then you write a colon, like you have written the colon for if conditions or for loops or any other constructs. And then you do indent, like the body of the for loop, like the body of the if condition. This is the body of the function. Body of the function should all be aligned. Then you write all the task, all the coding that you need to be performed whenever this function is invoked or called. This body can contain if conditions, for loops inside. This can have a whole lot of coding inside it. And whenever you will call this function, whenever you will type this command, wherever in your coding, the whole task under this will be executed automatically again and again whenever you like. So let's take a look of defining our first function in Jupyter Notebook. Let's just yes. So yeah, so that's our notebook. We were populating that notebook. So by the way, if you want to know where this notebook is located, if I want to for example invoke that notebook again, When you will run your Jupyter Notebook from the Anaconda prompt, you'll be having all the files that you are working on. And one file is, for example, this. You just click on that, and your file, one or more files, whatever you want to open up, that will open up in the Jupyter Notebook. Yes, so it is opening up. It's a lengthy file, so it may take a second. Okay, let me just take a better zoom level just to, okay, so we were working on that notebook. Let's define our first function. Let's say def define. Let's say the function name is print success. That's a syntax. Then you press enter. Print I am done. Then print send me another task, let's say, and that's it. Let's say that's the body of the function. The body of the function here contains only 2 statements. Okay, then you run this command just like shift enter. You run this so that it is reported in the symbol table. There is a symbol table inside the Python is maintaining all the variables, all the function information inside. So once you run this cell, then this print success function will be registered to Python, so that whenever you want to call this function again, it will be available. Now, if you want to perform this task, let's say you want to perform this task whenever you want. So you just call this function. This is called calling of the function, whatever I'm doing now. Print success, and that's it. You press shift enter, and all the statements that are under this will be executed. And you do some other stuff. Let's say 3 plus 8, that is 11. Do some other stuff, and afterwards, if you want to do the same process again, then you call this function again, and all the coding inside the function will be executed. It is very, very handy if a particular task, if you want to perform that task repeatedly, it is good to just write one code for that task in a function and then just invoke function whenever you need. It supplies a lot of managing power, a lot of debugging power. If you have an error, for example, inside the function, you just go to the code, you just go to the code of the function itself and fix the error and come back. You need not to go all over the code. If you have not defined the function and you have called these lines of codes everywhere inside your main code, then it will become very difficult to handle. And function actually provides a lot of simplicity of managing and readability and a modular approach in that sense. So that was our first function. We'll be talking about more. We'll talking more about these functions in the next video. So hope to see you in the next video. The function name should be descriptive. That's okay, but it is further important sometimes to have a documentation of the function, sometimes called the doc string. The doc string allows you to write the description of the function, but that description will never be executed. It will be available whenever you need help or you need to know what this function does. Sometimes it happens your function can contain a lot of code. For example, you have a particular function, let's say fun, let's say it contains def fun, and it does a lot of complicated stuff inside, and it is sometimes required to know what this function actually is doing. So this document string is one way of describing what the function is doing. You might be thinking that if you're writing this document string inside where the coding of the function should be written, we should open up the coding file and see what the function is doing, or should we actually open up this function implementation where the function code is written and then we have to read what the function is doing? Actually, Python gives you another power. If you have written the document string inside, that should be a top statement before the first coding statement. whatever description you want as a document string. It will be available without actually opening up, without actually seeing what inside the function, without actually opening up the file that contains the implementation of this function. Let's see in Jupyter Notebook in more concretely whatever I'm saying right now. So for example, let's define a function def print success 2. Let's say the function name, this function is print success 2. The function name is print success 2, although it's not a very descriptive name, but the spellings are also not correct, but that's fine. Print success 2. Here I just define a document string. The document string may contain maybe just in one line, or it may be a multi-line. It is like a multi-line comment, or maybe a single line comment if you want. But it starts with 3 quotes and ends with 3 quotes. Let's say I write here, this function is doing nothing except printing a message. Printing a message, let's say full stop. And then I further define, let's say I define more in saying that that message is hello, let's say, or any description you want for this function. Now this is a document string and it will be available whenever you need. Now here the coding starts. Let's say you write a coding here and you get hello, let's say, and you run this code. Now let's say we are not seeing this function. We are not available with this function. We are not available with the code of this function, and we want to know what this function actually does. First of all, we can just write, if we write pri and just press tab, the tab will allow us to access all the functions that are available with prefix pri. So let's say we go to print success, here print success, S should be capital, print success, let's say, so print success 2, let's say, and we write a question mark in front of it and then just press shift enter. It will pull the document string, whatever we have written, and we will get to know what actually this is doing. So this document string actually does a lot of job. Further, if we, this is kind of whenever we need to know what a function is doing, the document string is one way to just go and check what is happening. Right now, this function implementation is in front of us, but in several times the function implementation will not be in front of us. Several times we will be accessing functions that other people have written in their libraries. And we need to know what those functions are doing. So document string is one very, very healthy way of describing our function. And I will recommend to make your habit writing document strings every time you write a function. I was telling you that if you write a double question mark, then it will not only pull the document string for you, it will pull the whole implementation as well. So now if you see, this is the document string and that's the implementation. So whole implementation will be available if you want. And this is true for the functions that are the functions that are third-party functions, or some other person have written that function and so on. For example, a function length, we have called that function several times. So let's see. So the document string is return the number of items in a container. That length function is not written by us. Somebody have written that function. That's a built-in function, by the way. And this document string tells us, okay, what this function is doing. We don't have the implementation of that function. Obviously, somebody have written that function. And if we write the double, then we should get an implementation as long as the implementation is not in C++. I haven't told you that a lot of implementation of Python itself has been done in C and some other languages, C mostly. So several built-in functions, because of their speed, they are implemented in C. And if you if you want to get their implementation, get their code, the code will not be available for most of the functions. So so whenever you write a double question mark and the answer is the same as a single question mark, that's an indication that this particular function is not written in plain Python. It is written in some other language and is used in Python. That's another versatility or flexibility of Python. You can engage multiple languages inside. Okay, one more thing. I can write help command, and I can get this print success success2, the help of print success2 by just typing this help command. So this help will tell us, you see the help is telling us the document string. I mean this help on this function. And this is the function we have written. This is the function we have written. This function is doing nothing except whatever description we are giving there. If at some time, if we are supplying this function to somebody or making a package of a lot of functions that we are writing, these document strings will help to get to know how to use these functions. By just knowing the function name, this document string actually tells us what the function is doing. Wow, great. Oh, by the way, we haven't called this function yet. We are just playing with the document string. Let's call the function print. Now we know what the function is doing. Let's call this function. And whatever written inside the function will be called. See, this is only called. This is just acting as a comment, and it is basically a comment. Yeah? Okay, great. Stay with us. There is much more about function that we are going to tell you. Hope to see you in the next video. Okay, in the last video we saw document string. You might be thinking, what is power of this function if it is doing some static task? Well, in this video I'm going to tell you that the function the coding or the behavior of the function can be dynamic based on the arguments, based on some properties that you will be defining at the call time. For example, the function has, in almost all programming languages, the most interesting functions are the functions that receives an argument, and an argument is just considered an argument just as a variable, and performs its task according to that argument. Just take a simple example. Let's say rather than having a function print success, we have a function print message, and it prints whatever message it receives. And at the call time, for example, we call this function like print message, and let's say we call this as let's say success. Let's say now success will be printed. Next time we call the function and we give another argument, maybe in a string, let's say 74 errors, let's say, that will be printed, or anything. I mean, anything that you supply will be printed. Wow, isn't that great? I mean, one function, and you might be thinking, the plain print function does that. What's the power of this? Well, I'm just telling you, the function does not only contain one line. I mean, it can be a whole task depending upon this input argument, and the whole task will perform dynamically based on what input argument you are supplying there. You are noticing one thing that I just forgot. What is that thing? I defined this function. I guess everything is fine. I've just missed something. Oh, document string. I should have written document string. Although document string is not essential, if you do not write document string, it's perfectly okay. The function will run, but it's a good practice. It's a good habit to always write a document string. Okay, let's see the power of input arguments by, again, going to our good friend Jupyter Notebook. Okay, so let's see. Let's say we define a function, define print message, let's say, and it receives an argument message. And this argument is just a variable. It's just a variable. And let's say we say, okay, print message. Or further, let's say we say if is instance message string. If this is string, then simply print it. If this is not a string, then just say okay, print your input argument is not a string, and then you say okay, here is what you have supplied, and then you say okay, whatever you have supplied, just see okay message, and that's it. That's a function. We might have written a document string for it. The function prints the message supplied by the user, or prints that message is not in the form of string. Wow. Don't worry, we have to see the strings in detail. We will see this print function in detail as well, because this print has a lot to do with strings. So just for now, I mean, that's our function, print message. Let's say if the message is of string type, this string does not, this should be simply str, this should not be that, is instance take like this. Your input argument is not a string, here is what you have supplied. Here is what you have. So here we can say here is the type of what you have supplied, and then we can just print the type, type of MSG. So the goal here is to just write a function that prints a message if that message is in plain string form. If it is not a string, then it prints that okay, the whatever you have sent is not a string, it is not a proper message in string form. Let's say this print message function receives a string, let's say that's our logic or something. So let's run this. First of all, let's see what it does. Help print message. So the function prints the message supplied by the user. We can access the same help by question mark if we want, and it gives us the document string. If however we want the implementation as well, then we write a double quote, and the implementation is also available. Wow, great. Python is really great. Okay, let's call this function. Let's call this function. Print message, and whatever you want to print. Let's say this is the message. This is the message. Let's say you want to print this, and this is the message that's printed. Okay, now let's say you call this function again sometime, and you supply 23. And it will say your input argument is not a string. Here is the type of what you have supplied. It's an integer type. Great. You can call this function in the following way. Let's say you define a variable y, and the variable y contains hello. Hello there. Let's say that's your and then you call the then you call this function on y, and it will print hello there, because y is also a string. Great. So that's how you can pass different arguments and instruct the function how should it behave without actually writing the whole logic of the task again and again. You have written all the logic once. Actually, the logic starts from here. That's what the task is to. That's what the task you want to perform. And you need not to write this again and again whenever you need this kind of stuff. You just call that function, supply it arguments, and it will behave accordingly you want. Great. So you might be thinking that a function only receives one argument. Maybe we want to supply more than one arguments, maybe two arguments, maybe three, maybe four, maybe five, and maybe we want to supply several arguments, and we want to do some task based on the values of those arguments or those variables. So in the next video, I'm going to show you multiple arguments. Okay, hope to see you in the next video. So in the previous video, we saw we can define a function and we can supply input argument to it. And in this video, we are going to see that we can actually send more than one arguments to the function. These arguments are just variables. These are just variables. Whatever value we will supply to these dynamically, because Python is dynamically typed, dynamically their type will be defined. And for example, here we have supplied just two variables and we just printed them. But based on supplying more than one input arguments, and based on what logic we are going to perform, we can do anything. We can do anything. Yes, Python allows us to supply multiple input arguments to a function, and we can just perform all the tasks according to whatever logic we are going to do with that. So let's go to our friend Jupyter Notebook and see an example of a function with multiple input arguments. Let's say the function we define a function. Let's say my power. Let's say my power. Let's say you remember there is a POW function in Python. That's a built-in function. I'm going to write my own function. Let's say it contains A and B. Well, document string. This function computes power just like built-in power function. Great. That's the document string. Okay. Now what we want to do is we want to print. Okay. Let's create another variable C that is A power B. Okay. Then we print this C and we are done. Let's say that's our goal. So we register that function by just calling by just pressing the shift enter in Jupyter Notebook, and now we check what this function does. Well, this function computes power just like built-in power function. Okay, just to remind you again and again the importance of document string, I'm writing this again and again. Let's run this function. My power, let's say 3 raised to the power 4. I want this. So the result is 81. Oh my God. So whenever, by the way, if you don't have POW function with you, although you have, you can create your function, and whenever you want to use, you can use your function. Not a big deal. Yeah. By the way, what if you you can define a function with more than 2 arguments. Define, let's say, display types. Let's say that's your function, display types, and all you know is or check arguments. Let's say check args. Let's say that's your function, and A, B, C, D, let's say E, these are the input arguments. And let's say at some task you want to know whether all the 5 variables that you are working in somewhere, whether all of them are numeric values or not. If they're not numeric values, you're not moving on and you are doing something because you were let's say you're taking input from somewhere, reading from a file or whatever, and you need to check before moving on whether A, B, C, D, and E whether they are ints or floats. Otherwise, if any of them is not int or float, then you're not processing, then you're not moving on, and you're going to check the input arguments again and so on. These kind of functions are there because whenever you call certain, whenever you want to do processing on data, sometimes it is required to check the type of the data, whether the data is supplied in a way that you were expecting and so on. So let's have this function check args. I'm not writing document string here. I guess I've told you enough to write document string again and again. So let's say if is instance a, if is instance int float, if that is true, and is in, let's just have 3 variables just to focus on. If is instance A, then B, and is instance C, if all of them are integers or floats, then do something. Then let's say print A plus B plus C maybe, or A plus B plus C raised to the power 2. Just print their square, let's say. Else, or if they are all integers or floats, then do some interesting task here, some task. Otherwise, you can say, okay, print error. The input arguments are not of the expected types. Fine, you have this function. Let's call this function. The function was check args, so let's check args. Check args, let's say 3, 4, 5. So now you have, all of them are great. Let's say you have check args, and you call this check args on, let's say 3, 4, but this 5 is a string, let's say G. Now you'll be having an error. The input arguments are not of the expected types. One of them or more of them or whatever. Yeah. One more thing. This function is expecting 3 arguments. If you call this function by less than 3 or more than 3 arguments, you'll be getting an error. For example, 3, 4. Although this function is accepting 3 arguments, you're calling it with just 2, you're getting an error because you have not specified all the arguments that the function is requiring. Although the arguments that you have supplied, they are of the type that it is expecting, but you have not supplied the number of arguments that the function is expecting. Similarly, if you call this function by more than 3 arguments, although it requires 3 arguments, you again will get an error because it is expecting 3 arguments and you have not supplied 3 arguments. Later on, later on, we will see how to write a function that accepts variable number of arguments. We will see that, but right now in this particular way, if you write the function, if you define the function in this particular way, you have to define the arguments, the number of whatever the number of arguments it is expecting, you have to supply exactly as many. Otherwise, you are getting an error. Okay, so that's about the multiple arguments. Okay, what next? Well, next time, in the next video, we will see that what is the what's the importance of order of these input arguments? What will happen if I just swap message 2 and message 1? Will that change the behavior, or is there any order? The first variable, the second variable, third variable, is there any ordering inside the input arguments? Yeah, there is. So let's see in the next video. In the last video, we saw how can we how can we define a function with more than one input arguments. It is important to know that the order of the input argument is really, really important. So whatever argument at the call time, for example, if you call this particular function, the name of the function is f, that's not a great name. You should have a name that is descriptive, but I recommend to write good names. Let's say this is f, that's a function, and the very first variable is c2, the second variable is c1, the third variable is c3. Now let's say call this function like this, let's say 2, 4, and 9. What will happen is this 2 will be copied in c2, this 4 will be copied in this c1, and this 9 will be copied in this c3. Now c2 has a value 2, c1 has a value 4, and c3 has a value 9. If you change the symbols or the variables order here, whatever order you have written there, the first value that is passed at the call time will be passed to the first variable, whatever the name of the first variable is. The second value at the call time is copied in the second symbol, whatever the name of the symbol is. So this ordering is really, really important. One way to one workaround for this is at the call time, you actually define the variable names and their values. For example, you call f and you say, okay, c1 has this particular value, but this way you need to know that there is the symbol name in definition is exactly c1. So c1 has this value, c2 has this value, c3 has this value. Once you, at the call time, if you have defined your variable names along with their values, then you are order free. Now you change whatever, if for example you call this way, c2 is b, c1 is a. Now no matter in what order you have called these, this c1 is going to be copied in c1, this c2 is going to be copied in c2, and this c3 is going to be copied in c3. For the functions that has many more arguments, it is good to call the function in this particular way if there is a chance that calling a function in a different order may become confusing and stuff like so. This actually gives you more grip on this ordering issue. If you're happy with, if you're very smart and you say, okay, I will always supply in a particular order, I will always read the document string first and then I will call that function, that's okay. Otherwise, this is also a feature that is available. At the call time, you assign the values of the functions that are there at the definition time. And now, no matter in what order you are calling that function, C1 occurs at third position, C2 occurs at first position, the relative values will be copied according to their names. So, and that's a good feature. That's a very good feature. Let's see, for example, a running example of this in Python, in Jupyter Notebook. Okay, define, let's say function f. Let's say it receives a, b, and c. Let's say 3 values. And let's say it prints a is, let's say it's print a is a, and you say okay, b is b, and then it prints okay, c is whatever the value of c is, that's a c. Okay, now let's call this function f with, let's say 2, 3, and game. So we will say okay, a is 2, B is 3, C is game. Fine, great. Now this 2 will be copied in A no matter what. If we change this calling order, for example, if we change this order, we just move to this particular order. We just say okay, this is 3, this is game, this is 2. If we call like so, now 3 will be copied in A, game will be copied in B, and 2 will be copied in C. And that, if that is the behavior you want, then you are good to go. Otherwise, it is handy to call the function in the following way to just fix. Okay, A is 2, fine. B is 3. And C is, let's say, game. If you want these numbers. Now, if you call the function like so, that will happen. Now, if you change the order, no matter what order at the calling time you come up with, it will stay the same. For example, you go and say, okay, C is at the first position, and A is at the second position, let's say 2, and B is at the third position, 3, the output will stay the same. And that's a beautiful thing. So that's one way of handling with the order. If you think at call time it is important to define the variable names, but it has one problem, that you need to know exact variable names. If the variable name is C1 there, you need to know what it's C1. You need not to, I mean, the C1 matches with C, it must match with C1. C2 must match with C2 and so on. So you need to know these names. Okay, great. In the upcoming videos, more features of functions are going to be discussed. So stay with us. Hope to see you in the next video. So in the last video, we saw the ordering of input arguments in a function, and we saw a fix to it. I mean, if there is a chance that you may miss a proper order, there is a way to fix that. We saw that in the last video. Here we have another thing to discuss. This x variable, x input argument, this is the variable that is defined inside a function. Although the value it receives is copied from somewhere else, but it is defined inside the function. That is also the function variable, or the variable that is in the scope of the function, inside the function, in the body of the function, something like so. It may be handy, for example, let's say you compute something, you do some processing on your inputs, and whatever the result is, you save that result in another variable. And let's say now you need the value of this variable to do some further process. Let's say what you do is, let's say at the call time, let's say this is the function. Let's say this is the complete function, and let's say A is equal to 12 and B is equal to, let's say, 7. And let's say you call the function add AB. Now the value of A will be copied in X, the value of B will be copied in Y, okay? And now you need the sum of A and B to be received here in a variable. You want a variable in which the result should be saved. For example, let's say the variable is D, let's say. And then you want to do some more processing on D, let's say D double star 5 mod 3, and maybe you need to apply an if condition on that. If that equals to 0, then do some stuff otherwise. So let's say you need this variable out. What will happen is this C variable is not accessible outside this function, and the reason is the C is defined inside the function. When the function body completes its execution, the C is lost. C is no more available. C is defined when the function call has been made. When you are executing this statement, C is defined, and a memory location was created in a C, sometimes called the function space, in the memory or process space that is created in memory. But once all the body of the function executes, all the functions that were inside the variable, they're lost. How can you receive this value? How can you receive the value inside C outside this function? So that is question in this slide. How can we do that? Further, this particular function can access all the variables that are not defined in this function, but that are available outside this function and are defined already. For example, let's say I have a function f, and the function is, let's say I have a function f, and so if this function is defined like so, f, let's say f is your function, and it is defined like def, and that's it. And here it prints, let's say, some variable, let's say a. Let's now this a variable is no longer in f, not even defined in f. But as long as this a variable is defined before calling f, for example, that's the cell where we are writing the code, and we say, okay, a is equal to 7, and then we just call this f. Because a was available before calling f, a is accessible here. So the functions, the variables that are available before the call, they are available inside the functions. But the variables that are defined inside the functions, they are not available outside. That's a problem. Further, if we define this a here, a is equal to 2, now this a is sometimes called the local variable, or the function variable, the variable that is local to the function. Now this a is defined inside the function, and all the accesses to a will access this value 2 rather than the 7. Consider the 7 has a separate location in memory, and this 2 has a separate location in memory. Both have names a, but this a will only be referred to when the function is executing. After the execution of the function completes, this is gone from the memory, and this will still be available. This 7 will still be available. So it is good to know. And by the way, if a was not defined here and you still called f, then either you will be getting an error, or this a might be a global variable or available in some package that you have already loaded or stuff like so. In that case, this a will be accessed if it's a global variable or accessible. So it is good to know the scope of the variables inside the function, because when you're calling them, what functions, if x is already defined, for example, if x is already defined like 34, and then this x is 34 as long as this x is not defined here. If x is defined here, this x actually is the local copy, and that will be accessed inside the function. Once the function is gone, again x will be 34. So it is good to know the local copies or the function space itself. But the problem here is how to access this variable, the value of this variable outside the function, because this is completely defined inside. How to access that? Well, there is a fix, and that fix is called the return statement. If you write the return statement, for example, you return this value, so x plus y. You might have saved these values. For example, c equals x plus y. That's okay. And then you say, okay, return c. What will happen is, wherever you have called this function, d equals add, let's say 2, 3. Now this value c, which in this particular case is 5, that value will be returned in d. And all the properties of this variables are returned in D. So just like this C is copied in D, and this is available further, whatever you want to do with this D. Okay, so yeah, so return statement is there. So in the next video, we will actually code this in Jupyter Notebook and see the return statement running, and we will see the scope of the variables and all that in Jupyter Notebook. So hope to see you in the next video. In the last video, we saw scope of a variable, particularly if a variable is defined inside a function, is it accessible outside the function? And if a variable is defined outside the function, is it accessible inside the function, and vice versa, and so on. So we discussed those kind of things. which is sometimes called scope of a variable. And further we discussed what if we want a value of the function that is computed, value of some variable or some result that is computed inside a function. What if we want that to be accessed outside the function? So we discussed that in detail in the last video. So let's see all those concepts in a running form in Jupyter Notebook. So let's see how it works. So first of all, let's define a variable. Let's define a function. Let's say define, let's say my add, and let's say it receives two arguments. Let's say a and b, and then let's say c is a plus b. Let's say that's c, or c value. Let's say c value or some value, whatever you want to call that value, some value. That's it. Let's say we did that. Now we want to access that some value from outside the function. Print some value. By the way, let's first call this function. Let's say my add for values, let's say 2, 3. So 2 will be copied in A, 3 will be copied in B. So then let's try to access this value, some value. It will throw an error, and the reason is this variable some value is not accessible outside this function. What if we want to access, because this is defined inside the function, what if we want to access this, what if we want to compute some result and then use that result outside the function? So the way out, as discussed in the last video, is return statement, return value. And now if we call that again, if we call that again, now we haven't actually registered. By the way, remember this, that's a common error I got in that error many times. If you change the implementation of the function, you have to rerun that cell. You have to register the updated copy of the function to the Python. Otherwise, you will be getting errors, probably. Yeah. What's the problem here now? Print some value. This some value is still not accessible, because some value is not accessible. It is a variable defined inside the function. It is the scope of this variable is just the body of the function. So let's receive this output in a variable d, and then let's just print d, and d is 5. Great. So one more thing, let's say we define a variable here, a variable outside the function. Let's say that's a variable name. That's a very lengthy name, but let's say that's a name. Variable outside the function. Let's say its value is 3. And then let's define another function somewhere. Let's define another function down somewhere. Let's say define f, maybe g, and it receives nothing, but it prints this, let's say variable outside the function, and that's it. Let's say that's a function. Now when we call this function, this variable outside the function, that is accessible inside the function. And if this function, and if this variable, it is not defined inside here, and if this is defined somewhere else and it is global or accessible, it will still be accessible. However, if we define a function with the same name, let's say variable outside the function, let's say 5. Now this function will print 5 because that's the local variable, in the function. Now this will be accessed in this print statement. Let's see. Now the result will be 5, but if you print the variable outside. Now the value will be 3 because this variable, this particular variable that was inside the function, it got destroyed when the function finishes, and this is available again. So yeah, so you need to know, by the way, it's a good practice whenever you want to access particular variable inside, it is a good practice to pass that variable as input argument to minimize the confusions, because this can create a lot of confusions. So it's a good practice, although the feature is available and sometimes useful as well, but it is always recommended to pass the values as input arguments, that whatever you want to access inside the function. Okay, so one more thing, this function g is returning nothing. For example, it is not returning anything, it is just printing, let's say, something. Let's say it is not printing anything. Let's say this is a comment. Let's say it is not printing anything. So this, and then we call this, and that's it. So it has no return value. By the way, in Python, even if a function does not return anything, it still returns a value which is called none, which you can see here. So in Python, a function always returns a value. If you write a return statement explicitly, it returns that. If you do not write return statement, when the function body finishes, it automatically returns none. Let's see the type of this output. What is the type of this output? What is the type of this none? What kind of data type is this? Let's see. It's a none type. I mean, that's a type in Python. So it returns a none type output. How fancy. Wow. One more thing, the return statement is not only used to return a particular value. If you, for example, in a particular function, let me write a function here. Let's say def, let's say the function is h, and then inside that function you do something, let's say print a, let's say then you define a variable, let's say a equals 2, 3, let's say, then b equals, let's say 5, and then you add those values a and b, and then you do some other stuff, let's say print something, and then you just write a return statement without any output, or I mean it is not returning anything. You can still I mean continue writing the function body more and more, but what happens is whenever the first return will be encountered, the function returns from there. So the effective body of the function is just that. The function returns right from there. If you return a particular value, for example C, you can receive that value outside the function. If you do not return anything, just type a return statement. That means exit the function right away. It works like the break statement in loop. Remember the break statement? It resembles to the break statement. Return means just exit the function right away, no problem. And by the way, when return is called, the default return value that is returned is none type if the return is called without an argument here. So for example, let's run this function. Let's see, and let's call that function h. Yeah. So it prints a, then it prints something, and then it returns. And it returns, for example, it returns nothing but a none. Yeah. It returns a none. And if you return C, for example, C, then it returns a C, value of C, which is 8. And this time, the return value is no longer none type. It is probably an integer type. Let's see. Yeah. Here. So it's integer type. Make sense? Yeah. So return statement has two purposes. One, you can return a value. Two, you can return, you can just return the control. You can just exit the function like the break and loops. Just one more thing. A return statement can return multiple values. For example, let's say we have defined a function, let's say j, let's say g we already have defined, we can redefine it, but let's say R is our function, and we just have A equals 5, B equals 7, and D equals, let's say, something. And then we just return them A, B, and D. So return statement can return multiple values in a sequence. Now if you receive those values, let's say X, Y, and Z equals R, so A will be copied in, A is the first return value, it will be returned in X, it will be copied in X, B will be copied in Y, and D will be copied in Z, just as a sequence as you keep the sequence in the return statement. If you change the sequence in the return statement accordingly, so whatever the first value here is the first value here, whatever the second value here is the second value here, and so on. So let's run this and just print all these things X, Y, and Z. So yeah, 5, 7, and something. So this return statement is really powerful. I mean, it can return multiple. Not all the languages actually, they have feature to return multiple values, but Python does have feature to return more than one values, and more than one values of any type. A can have different type, B can have different type, D can have different type, and so on. So that's about the return statement, as well as the variable scope, and whether you can access a variable that is outside the function or inside the function, and so on, and all that kind of things. In the next video, we'll talk about what if we want to access arbitrary number of input arguments. I mean, we do not know how many arguments will be there inside, but no matter how many arguments a particular user is giving, let's say we want to write an add function, just to give you an example. Let's say we want to write an add function. Let's say define add, let's say add2, another function add2, and let's say it receives an arbitrary number of arguments, D in, I don't know how many, and it has some implementation. Then anybody who want to call this add2, if that person gives two arguments, then just 2 should be added. If the person gives 3 arguments, then 3 should be added. I mean, the person can give arbitrary number of arguments. How can we handle that? Because the caller, this is the call. The caller can give 5 arguments, 6 arguments, 7 arguments, and earlier we saw in the definition the total number of variables. When we specify, we have to pass those many arguments for sure. If a single argument is missing, or a single argument is just more than the specified number of variables, we will be getting an error. But how can we handle this situation where we have an arbitrary or variable number of input arguments? How can we handle that? So to answer this, or to get how can we do that, see our next video. It's coming. Yeah. So in the last video, we were talking about how can we handle arbitrary number of input arguments. For example, let's say we want to write an add function that should be able to add any number of, let's say, integer or floating point numbers that are passed in. Remember last time we discussed in an earlier video that when you are defining a function, the total number of variables that you are defining, you have to pass exactly those many input arguments, otherwise you are getting an error. But this may be required sometime, that we want to add a universal kind of add function that has capacity to receive any number of arguments, but no matter how many arguments it receives, it just add them all and return the result. Such a function, if available, will be very, very helpful, because sometimes we might be calling that function by just 2 arguments. Sometimes we might be calling that function with, let's say, 3 arguments, and sometimes more arguments or less arguments, and so on. How can we have this kind of feature available, but the implementation is just one-time implementation? Well, Python have a very, very easy way of handling this arbitrary or variable number of inputs. And the way you do that is when you are defining a function, you just write a star and then just print, let's say, one variable name, let's say args. And then after that, this args will act like a list. And I mean, it will be having a lot of properties. Args, this args has a property, this acts like a list, so all the arguments that you will send in will be received like you're receiving those in one list, and all the elements which are the arguments in the list, they are accessed by different indices. We will see lists in detail later on, but right now just think it is a collection, all the collection, it is received by indices. For example, the args, the very first element is indexed by 0. It is at the 0th location. At the 0th location, there is a 3. At the first location, for example, the location index number 1, which is actually the second look, the 4 will be copied at this, and so on. Now, no matter how many arguments you pass, a list, it will be of that size. And there is a function length, len, that is handy to just check how many arguments are there. Now, if you pass 2 arguments, the length of the args will be 2. If you have passed 3 arguments, the length of the args will be 3, and so on. No matter how many arguments you pass, this args, it will receive all them in one by one, and all the elements in that arg will be indexed by 0, 1, 2, starting from 0 until the length of the args. So see, for example, here, the sum equals 0. Let's say we want to add all these. For I in range, and inside range, we just give the length of args. For this example, 1, 2, 3, 4, 5. The length of arg is 5. So I will start from 0 till 4, because 5 is not included. So the very first time I will be 0, and args in subscript 0 is actually the value of the first variable, which is 3. So 3 is added to 0. Then next time I will be 1, and at the position 1, 4 is located. So 3 plus equals 4, which means 3 equals 3 plus 4. Sum equals whatever the previous value of the sum plus 4. Then next time the value of I will be 4. You know how this loop works. We discussed the loops in detail. And as you move on, you actually explore all these numbers, and this variable sum actually contains the sum of all the variables. Now you can return this sum, and this particular function acts like a universal kind of function that receives arbitrary number of arguments. How cool is that? Let's see in Jupyter Notebook to get more convinced how it works. So let's say we have define, let's say we have any function, my add, let's say that's function, my add powerful, let's say, yeah, universal or universal, my add universal, and it receives star, whatever the variable name is. You can write the name args, or you can write any other variable name. This is just a name of a variable. Okay, then let's say we have s equals 0, which is sum. Then we just apply a loop. I guess you know the loops. We have lengthy discussion on loops. In range, length, that's a built-in function, length, args. Okay, then what should we do? S plus equals args I, which means access all the elements one by one, and this is again the same as s is equal to s plus args I. Either way you write this way or that way, both ways are fine. Then when the loop finishes, s contains the sum, just return it, and you are done. Wow. Now let's call this add function my add universal, and let's call this function as 2, 4, and 5 for these, and let's just print the result. Okay, the result is 11. Wow, because 2 plus 4 plus 5 is 11. Now let's call this function for, let's say, for let's say 5 arguments. It works. It adds all these 5 numbers. Wow, that is great. I mean, now we can add any, we have one function. We need not to write a function for 2 arguments, and then another function for 3 arguments, then another function for 4 arguments, and so on. depending upon the number of arguments, we need not to write separate functions. We have just one function working in all scenarios. Wow. So yeah, that's doable. I've done in front of you, no problem. Yeah, Python allows this. Yeah. In the next video, we are going to see how can we actually handle the same kind of scenario, but we want to handle the sequence of the input variables in a very controlled way. Remember in some of the previous, in this order of input arguments, remember that we received 3 arguments and we passed the 3 arguments in a very controlled way. And then whatever these are, we don't care. Whatever the order here, we don't care. What if we want to fix the input, or we want to become more careful for input argument orderings, but then we also want the arbitrary number of arguments? How can we do that? Yeah, wait for the next video and I will show you how can you do that. In the last video, I promised you that I will show you how can you achieve the ordering of the input variables but still having the arbitrary number of them. Remember, this looks like much familiar to you. That's a call that can be made to a function, and remember the function definition in some previous slide was like C1, C2 and C3 maybe, and then something. What if we want an arbitrary number of arguments to be passed, but we want they're controlled? For example, let's say this particular variable symbol name that acts as a key, that's a variable name and that's the value. So let me call the variable name as a key, and this is the value that is copied in the variable. That's another key, that's a value. That's another key, that's a value, and so on. What if we have a lot of key value pairs? What if we have a lot of them? And we also want to check which value is of what key. Let's say we want to specify those, but we want to specify an arbitrary number of them. Let's say here, for example, there are only 3. Let's say we want to pass 5 of them, 6 of them. And then we want our function to perform accordingly, no matter how many input arguments it received. Yeah, and maybe inside the function, we may have applied a check that if the key value is C1, then do this processing. If the key value is C2, then do that kind of processing, and so on. Let's say based on different variable symbol names, we want to process the value differently. How can we achieve that and still having the need that these number of variables can be in a variable length? They can be an arbitrary number of those. So Python gives you again a very, very simple way. Rather than writing a single star, you write a double star, and then you receive in whatever variable name. And now in this double star means you are receiving a key value pair list. It's a list of key value pairs. We will see that resembles to a data structure in Python called dictionary. We will see dictionary later on in detail, but right now just consider that this input argument, this input variable C, it contains a list of key values pairs. And then you can just iterate over this C. You can just apply a for loop to check the contents of this. Remember, we have actually done that kind of thing in the portion of loops. Yeah, here. Remember, that was a key and that was a value, that was a key, that was a value, and we did that thing. We could explore we were able to explore the dictionary just using for loop. Yeah, it's the same thing here. It's not exactly, but you can think of that. That's exactly the same thing. So you can explore that C looks like a dictionary now. This is key, this is value, this is key, this is value. This is key, this is value. This X points to the first key, then C of X points to the value based on the key X. And then X points to the second key, then the second value, and so on. That is very simple procedure. You are just printing all the dictionary, but you are printing all the variable names and their values, but you can do very complicated processing if you want to. Let's go to our friend Jupyter Notebook to just get convinced that this indeed works. Let's see. So let's define a function first. So def, let's the function name is print all variables and values. So that might be a function name. Wow, that's lengthy one, but descriptive one. Maybe we can make it more descriptive. Print all variable names and values. Wow, that's more descriptive, I guess. So it receives, let's say, double star any variable. Let's say the variable name is, again, let's say args or anything, whatever you want. Then what we do is for x in args, just print, let's say, variable name is, just print x, and then okay, just print x, and then just continue, and value is args of x. So let's say you did this. So the variable name is this and the value is this. Okay, and you want to do this for all the variable and value pairs that you send at the call time. So now let's call this print all variable names and values, and let's call this, let's say the first variable name, let's say, is a, and its value is 3. The second variable name is, let's say, b, its value is capital B. Let's say the third variable name is c, its value is ccc. And let's say the fourth variable name, I mean, you can define an arbitrary number of arguments here. Wow, that's amazing. Let's say the fourth variable name is y, its value is 6.7. and further notice, you can pass a variable and value, all have different types, I mean different number of them, and much more. Yeah, you can do that. So let's call this function by just having 4 variables and their values. Let's see what we got. So variable name is a and the value is 3. Variable name is b and the value is b. Variable name is c and the value is ccc. Variable name is y and value is 6.7. You can give an arbitrary lengthy list here if you want, and Python just allows you to do that, and it allows you to do that in a very, very simple way. That's amazing. That's amazing. I mean, that's what a high-level language, or really a powerful language, should have a feature. So Python does have this feature. I'm really amazed. I really astonished Python. By the way, I'm not saying the other languages don't have this. Several languages actually support this kind of feature, but Python supports it in a very easy way. It's very easy to do that. I mean, it's not a rocket science. Yeah. Okay, so now we have handled an arbitrary number of arguments, even with ordering is really controlled. We have 1 or 2 more videos on functions just to explain a bit more. Then we will practice on Jupyter Notebook. We will play with these functions a lot, and we will be calling one function inside the other function and so on. We will be having one better program, just program a new Jupyter Notebook just to get comfortable with these functions. But before that, let's have 1 or 2 more things to discuss about the functions. Yeah, let's see. So hope to see you in the next video. Okay, I really want to talk about these default values for a function as well, because that's important and mostly needed. The default value is a value of the input variable that you assign while you are defining a function. And if the value is, for example, if you call this f with, let's say, the input value 3, then 3 will be copied in the sum and the print will be 3. But if you call this function without the input, then this value acts as if you have passed this. So this is the default value. If you do not supply the value, this is the value that is going to operate. And by the way, you can have multiple variables with default values, some variables with default values defined, some variables with default values not defined, and so on. So you can have this. One care must be taken here that the default value, when you actually define the function and you compile this function, actually you run the cell shift enter in Jupyter Notebook, at that very time this variable is assigned this value at that particular time. It is not assigned at the call time. So sum equals to 0 is already there when you actually press shift enter for a cell that contains this code. Now later on, if you pass a value, that value will be overwritten on sum. If you don't pass the value, the 0 will go on. It looks like very easy. But one care that I want to mention here that I haven't mentioned earlier. In Python, there are certain variables that are referenced rather than copied. I will discuss the referencing and the copying in detail in data structures, but let me just tell you one example. Let's say you defined a list, let's say 1, 2, and 3. And then what you do, you copy this list into another variable, let's say L2. What will happen is in the memory, this list in a particular way, this is not the exact view of the memory, I'm just showing you. Let's say this is the particular memory layout for which this L is pointing to. This L is labeled for that. L2 is also labeled for that, which means actually in memory, this is not the copy of the structure that is made. I mean, this is not like in variables, for example, if A is equal to 3 and B is equal to A will be a position in memory and B will be a separate position in memory. That is what a view of the memory in ordinary variables are. But there are certain variables in memory just for memory efficient and code efficiency and time. People have designed these data structures in a way that when you copy them, when you just assign a variable to another variable, the memory view doesn't change. It's another name for the same memory location. So what happens is if you change any value in, let's say L2, at the zeroth index, let's say you change that by -9, because it is the same view in memory that changes -9. And now if you print the elements of L rather than L2, you will get the changed value. You will see the changed value, and that happens. Now, why that is important in terms of these default values here for the function? The reason is if you are accepting a list, let's say the default is a list, and you're accepting a list and you are also defining some default value for the list, if that's your definition, let's say, then this default value is assigned at the very first time, and this L is really a local variable inside the memory. Now, once this cell is run, not the call time, at the so what called the compile time, when the cell is run, this L is assigned this, and that just happens once. Now, if you call this list with some other list, let's say L2, let's say 2, 3, and 4, then if you call this L2 will go there, it will be copied in L, and everything is fine. But don't then expect the contents of L2 to stay in L, because L is this default values, they are assigned just once and they stay as it is every time you call the function. They don't change. They are not assigned at the call time, they are assigned at the compile time, and they stay fixed. So that care must be taken. I will show you that particular example in Jupyter Notebook shortly. This might be confusing right now because we have not seen lists in detail, but I just want to make this point. I just want to mention this because that's important difference with ordinary variables. That default value is just like a value, and if you don't supply a value, the default value just works. But with the variable that are reference type variables, you may expect something else, and the Python function behaves maybe differently, and that's because these default values, they are assigned at compile time. They are not, or compile time, actually this is not a compiled language. I should not use the word compiled again and again. Just think, when we define this function and we run the cell at that particular time, the default value is assigned, and the default value never changes. It stays fixed. Yeah. So, and I will show you that example. Why don't we move to Jupyter Notebook and see that example? Yeah. So or why don't we do that in the next video? What do you think? This video? Okay, same video. Okay, let's go to Jupyter Notebook and see the default values. For example, let's say we have define a function, let's say gg, and the default value s is equal to 4. Let's say that's a default value, and we want to print, let's say, s if available from the call time. If not available, then 4 will be printed. Now we print. Now right now we are going to print. Now we are going to press shift enter. At that time s is assigned to 4. S has now value 4. It is assigned there. Now we call gg, let's say, and we call gg without input arguments. Now the 4 will be printed. If we call this gg with some input argument, let's say 56, now the 56 will be printed, no problem, everything is fine. Let's see about the lists. For example, let's say the list is, let's say 1 2 3, that's a list, and then L2 is simply, let's say L2 is L. Then what we do is we change the contents of L2. Let's say we change the very first value in L2 and we place that value as -9, and then we print L. Now you might be expecting that L is a different thing, L2 is a different thing. Because L and L2, they both are pointing to the same memory, the content through L2 actually changes the memory view, and L also changes, and that gives the result -9 in L. Well, the behavior that I want to show you is different in the default values when we talk about. For example, let's say we define a function ff and it accepts a list, and the default value is empty list, or the default value is, let's say, 1 2. That's the default value. Let's say if no list is passed, the default list is 1 2. Now in this particular scenario, if we just print, so for example, for I in list, print I, let's say we just print all the list, and that's it. Now we will press shift enter, and at this time this L is assigned this value, and that's a default value that is not going to change. Now let's say we have an L2 that is simply, let's say 2 3 and 4, or let's say 12 3 and 4, and what we do is we call ff and we just press shift enter. Now oh, why not? We call ff without anything, so the default list is printed. If we call this ff with L2, the L2 will be printed. Now notice that this L2 actually is copied in this L because we supplied it. So L and L2, you may tend to think that L is now also pointing to L2. I mean, L has also the same contents as L2. So if next time, because of the behavior of these lists, because they are by reference, next time you might be thinking that because L2 is passed there, so L2 is copied in L in a memory view layout, so L has also the same data as L2, and next time if we call this function without input arguments, then L might be pointing out to L2 values, so 12 3 and 4 might be printed. But that is not going to happen. The default values, they never change. Again, you will be getting 1 2. So the behavior of these reference type variables, that is different ordinarily, but when you do that in the default value structure, that might work in a different way. And the reason is you must know that these default values, they are assigned at the time when the function is created, not at the function when the function is called, and they are not going to change whatsoever. So that was about the default value. By the way, the default value was a simple concept. I guess I have made it too complicated by telling you lists and default values and the creation of these variables at what time and at the call time. I made this complicated, I guess. I shouldn't have told you the list values and all that stuff, but that's true. I mean, whatever I have told you is true. Maybe I have told you in a very complicated way, but it's true. Yeah. Okay. One more video on the functions, and then we'll be practicing the functions in detail on Jupyter Notebook. So just bear one more video with me. Hope to see you in the next video.